In this lesson, we will finally start building our RESTful API, and we're going to begin by adding support for getting resources. In the previous lesson, we introduced our first entity, a habit, and we configured EF Core and created the required database structure. Below this video, you will also find a SQL script that you can execute on your database to seed some initial habits so that we have what to work with when we start implementing getting resources. So let's begin our implementation by adding a controller. I'm going to add a new class and I will call it the habits controller. The naming convention I like to follow is using plural nouns for my resources, and my controllers all inherit from the controller base class. We're going to decorate them with the API controller attribute, and I will also decorate my controller with a route attribute, and the base route is going to be habits. I won't be using an API prefix because I don't see value in using this approach, and just using a simple base path is more than enough. So what do we need to implement getting resources from our controller? Well, first we're going to need our database context. So let me inject the application database context as a service inside of my controller, and I will be using the primary constructor feature for dependency injection. Then we need to define a method, or because this is a controller, we can also consider this an endpoint, but because we are still in the object-oriented world, it's not a mistake to call this a method. So what is this method going to return? Well, the simplest result type you could return is the iActionResult interface. You can see I'm already getting a completion that could satisfy what I need to implement the initial version of the getHabits endpoint. Now, we also have to decorate this with one of the HTTP method attributes, and in this case I'm going to say HTTP get. And this is the simplest possible way of how we could implement getting resources. So let's actually start the application and see if this is working as expected. I will jump into Postman, where I already have a Postman collection containing the API requests that I will be needing throughout this course. So I recommend that you download this Postman collection right now, and we're going to make any updates that we need as we go along the way. So let me send a GET request to my base URL, which is https localhost 5001, and the base address for my controller is just habits. If I send this request, I will get back a response that gives me back all of the habits that I have inside of my database. I have a total of 10, and you can see all of them are returned as a top-level collection. Now I'm doing this just so we can confirm that everything is working as expected and our database is properly configured. Now let me try to do something else. I want to specify a custom accept header. So let's say I say accept, and I'm going to specify the value as application JSON. And if I send this request, I will get back an identical response. Now, what if I wanted to return something else like XML instead of application JSON? If I send this request again, and let me do it another time, you can see that I'm still getting back a JSON response. So even though our controller is working and we are getting back the habits resource, some things aren't working as they should. So let's make a couple of improvements to our implementation. First of all, let's tackle content negotiation, which is what we were doing when I was specifying a custom accept header. When I'm calling the add controllers method, I have an option to pass in a delegate. And here, one of the properties that I can set is returning HTTP not acceptable when I specify an accept header that's not supported in my application. One more thing we will need to support XML responses is adding the XML serializer formatters. So I'm first going to run the application without this line of code and show you what happens when we send the same request. If I send a request where the accept header has a value of application JSON, you can see that I'm getting back a response. However, if I set application XML in the accept header and send a request, now we are getting back a 406 not acceptable response. It means the server doesn't recognize this content type and it responds with a 406 not acceptable response. Now let's go ahead and uncomment this, and I want to add support for XML serializer formatters, and let's restart the application. And now if I send the same request with the application XML media type, you can see that we are getting back a response that contains the habits resource serialized as XML. So this is how you can support JSON and XML content negotiation inside of your API. Let's omit this for the time being, as I will mainly be using JSON responses going forward. The next thing I want to discuss is the actual implementation of getting back resources. There are a couple of problems here, and we're going to tackle them one by one. First, we are returning all of the habits from our database. This is something that we will tackle in an upcoming lesson where we discuss pagination, but the bigger issue I have here is that I'm returning a list of habits, and the habit is our entity type. This is problematic because I'm coupling my internal contract, the habit entity, to the external contract, which is what I'm returning from my API. So how we can solve this is by introducing a so-called DTO, a data transfer object, that's going to represent our external contract. This is what we are going to expose from our API to our clients, and this has a lot of benefits. First of all, we are decoupling the internal contract inside of our solution, the habit type, from the external contract represented by our DTO. I'm going to create a top-level folder that's going to contain all of my DTOs, and I'm just going to call it DTOs. Then inside of it, I will create a habits folder that's going to contain the DTOs related to the habit resource. And finally, let's create our class, which I will call habit DTO. Let's make it a sealed type. And there are a couple of naming conventions that you will see when it comes to naming your DTOs. A common one is using request response to represent your incoming and outgoing DTOs. So for example, we could have a habit request. For example, when I want to create a habit, I could define a create habit request. And when I want to return it, I can create a habit response. Now, another common naming convention you will see is using model instead of DTO. So we have a create habit model and a habit model as the response. Or we can just use DTO, which is simple enough, and we know explicitly what it means. Another thing we should consider is if we want to use classes or records to represent our DTOs. Records have the semantic advantage that they are immutable, although you can get around this by giving them setters, and then you just make the whole idea pointless. And another quality of records is that they support structural equality. So I'm going to save us some time, and I will paste in the implementation for my DTO. It's basically a one-to-one copy of what I defined in my entity, except I'm using get and init to define the properties, which means you can only set them once. And I'm also flagging them as required so that we don't forget to set the required properties when we are mapping them from the database, for example. For the complex types inside of the habit, I created separate DTOs, and the benefit is we will be able to reuse these when we want to support updating this resource, maybe even with partial updates, and I'm just explicitly specifying the enums without mapping them to a primitive type. So now let's go back to the habits controller and see how we can rewrite this to return a habit DTO instead of returning our internal contract. The best solution would be to apply a projection inside of our SQL query where we select a new habit DTO instance and we map all of the properties from the habit into the habit DTO. You can see that the required members are also helping us here, letting us know what are all of the properties that I have to set when initializing a new habit DTO instance. I'm going to add all of the mappings that are required for this to work, and you can see that this is becoming a pretty hefty select statement. But essentially, we're just mapping from the habit entity into the habit DTO by mapping the properties one by one, and I'm also initializing the complex types. For the milestone, we could expect a situation where the milestone is null, and in that case, we're going to return a null response. Otherwise, we're going to initialize the respective properties.